Hey, Nevaeh, this is question number 36 or 37. I think this is on page 4 or page 6, I forget. But anyway, it is a problem that's dealing with recursive functions, recursive sequences, and exponential functions. Um, and the reason that I gave you this question is I wanted to make sure that you know how to calculate the rate of growth or the rate of increase when you're given when you're given something here. So let me do this. All right, so this is they've given us a recursive formula where A sub 0 represents the initial population in 1910, N represents the number of years. So N is the number of years since 1910. A sub 0 is the population in 1910. So the population in 1910 was 92.2. I guess that's million. Yeah, it's million. And then this is the formula that's going to tell you the growth. Now, the fact that this number is over $1 means that it's increasing. The question is, they want to know how much is this increasing. And all you would do is what you would do if you had an exponential function. This is basically $1.015. It's not $1.15, it's 1.5 cents. And to find out how much it's growing by, you just subtract $1. So this is going to be 0.0015. So it's increasing by 1.5%. Okay. Now, if you aren't sure, let me show you how you can check what the rate is. If you go to the calculator, where is the calculator? Right here. Now, in the from the calculator homepage, if you go down here, it's next to the G, and you click on that. That's the percent symbol. So what we're going to do is we're going to put in 1.5%, and we're going to see what it looks like as a decimal. So that's what it should look like as a decimal. If you look at the iPad, that's exactly what we have here. So those two are equivalent. So the percentage rate of growth is 1.5%. Now, the second part, it says write an exponential function where P of t that represents the population in millions, where t is the number of years. So instead of being n for the number of years, now we're going to make it t the number of years. So we're going to have p parentheses t equals. Now we need the initial population in 1910. So that's going to be 92.2 million. And then we want to know what's the growth rate or growth factor. Well, this is it right here, this part in the front. So we're going to put $1 and 1.5 cents. That's what we have in there. And then all we need to do is put a t here. So it's a function of time. It's a function of the number of years. So that's the function. Now, it says, according to this model, determine algebraically the number of years it takes the population to be approximately 300 million. Round your answer to the nearest year. All right, so what I'm going to do is, I don't know. Well, so basically this is what we're doing. You can do this graphically, by the way. So I'm going to show you how to do it graphically. We're going to do 300 equals 92.2 1.015 raised to the t power. So let's find out what the answer is before we try to do any algebra. So if we go to the graph, we go here. We're going to put it in function mode, so menu 31. All right, and then we're going to do 300. And then we're going to do the 92.2 times parentheses 1.015 close parentheses raised to the x power. Remember, we can only graph x's, right? And then we're going to do that. Now, you don't see the graphs. So if you don't see the graphs, use menu 5. Whoops. menu 5, and then 1. And now that's the 300 million. But what we need to find is where is the other function. So let's do that. And there it is. Now, I'm going to zoom out until I find where they intersect. So I'm going to go menu 4, 4, and then I'm just going to go out, 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 out. All right, so now I'm out and I can see the intersection there. So what I'm going to do, let me move this out of the way. Let me move this over here. I'm just going to do menu 64 for intersect. So I'm going to start here and I'm going to pull it past, and it tells me we want the X value. So it says it's going to be about 79 years. 79 years to get to 300 million. We started with 92 million, and it's going to take us about another 79 years. So that'll be like 1980, 89. We have 300. Now, actually, that's a little aggressive. We didn't get to 300 million, I think, until like 2000. But anyway, that's the answer. So T is equal to 79. T is equal to 79. Now I'm going to try to do this algebraically. All right, so now, first thing I'm going to do is divide both sides by 92.2. Right, that cancels. And now what I'm going to have, I'm going to write it down here. It's going to be 300 divided by 92.2 equals 1.015 raised to the t power. Now, to get rid of the t, we're just going to take the log. So we're going to take the log of both sides. So we're going to take the log of this side, and we're going to take the log of this side. So so that's going to be t log 1.015 equals this, and then we just divide both sides by the log of 1.015. So this is going to be the log of 1.015. Okay, so these cancel out. So our answer is going to be t equals, let me see, it's going to be a log of 300 over 92.2. And then we're going to divide it by the log of 1015. So let's go to the calculator, go to the home screen, and then I'm going to do control divide for stack fraction, and then I'm going to use the log, and I'm going to leave it as base 10, and then I'm going to do control divide here. That's going to be 300. And this is going to be 92.2. And then I'm going to go down to the bottom. I'm going to put a log in there as well. And then I'm going to put in here 1.015 and then press enter. And there we go. It's 79. We knew that. We already knew the answer. So that would be our answer, 79 years. So if I go back over here, you can see that our algebra gave us the same answer as when we did it graphically. So we've checked it. So that's it. That's it, guys. All right. Now, a couple quick things. Whenever it says algebraically, that should be your clue that you can graph. You just have to know what equation. So they're saying this was the function, we set it equal to 300 million, and then we just graph it and find where they intersect. That's what we're doing. Because if you do that, I think if you do it algebraically, you get 2 points. If you just put the answer, you get 1 point. So it's not that big a deal on that one. So I'm going to stop this and post it.